Hello everybody, it's James and I'm back in the shop again. Today we're going to do a project that I've been wanting to do for a long time. It's going to be building my own drum sander, my own thickness sander. And let me explain the reasons why. As you've seen in my other videos, I have a very good planer, but it's only a 13-inch planer. And some of the things I'm starting to make now are going to be between 20 and 22 inches wide. And that won't fit through the planer. So when I do glue ups, whether it's be for clocks or for my game boards or whatever it is, when I do a glue up that's bigger than 13 inches, I have to go out and use a belt sander to try to get everything as flat as I can. And then when I go to put it on the CNC machine, sometimes it's 3 to 4 or 5 thousandths off. So when I do an engraving or when I try to write words, some of it's deep and some of it's not. So I need a thickness sander to get everything as flat and true as I can do it. Now, here's a couple of thickness sanders that you'll find on the internet. So this is a 24-inch thickness sander from Grizzly. I love Grizzly tools, but I don't have $2,000 and this one's on sale. It's normally more. This one from Jet is only a 22-inch thickness sander, and it's nearly 18 before shipping. So I had to find a new solution. But there's a guy out there named Stumpy Nubs, and you've probably seen some of his videos if you're woodworking on the internet, or if you're woodworking in your shop. And Stumpy makes a lot of wonderful machines. He gives a lot of good tips. Go to his YouTube channel and subscribe to him. It's Stumpy Nubs, a guy named James Hamilton. And he put up a video and some plans for a 20-inch thickness sander. So I bought his plans, and I'm going to modify it a little bit to be a 22-inch thickness sander, because that will fit almost everything that I do. So let's get started. I'm going to show you some of the parts that I've already purchased, and we'll get started cutting out the pieces for this thickness sander. So these are some of the parts I had to buy to build the thickness sander. The drum is going to be built out of this heavy-duty PVC 4-inch pipe. That will be what the sandpaper is wrapped around. Most of these parts were very available at Home Depot. There's a complete parts list on Stumpy's plans. By the way, his plans are only $10. I'll get back to more of that later. But basically, washers and nuts and threaded rods. And then I had to go out on the internet and buy 2 pulleys to go onto this motor. And the motor I got from a fellow who was parting out a table saw. So I got this motor for $20. It's a 1 horsepower motor. I'm hoping that's not underpowered, because Stumpy recommends a 1.5 horsepower, but we'll see how that works. So I have a pulley that fits on the shaft and a bigger pulley that'll go on the drum, and this will reduce it from 3,400 RPM down to about 1,750, which should be appropriate for a drum sander. And so let's get started putting this whole thing together. There's one other thing I'd like to mention. For those of you who already have a CNC machine, and for those of you who use a program called VCarve from the Vectric company, I've already programmed a lot of the parts for the sander to be cut out on a CNC machine. The dimensions and things like that are pretty precise. So I have programmed in several different VCarve files a lot of the parts that make up the sander, and I'm going to be cutting out some of the smaller parts, the wheels and the drums, the plywood parts that would be a pain in the neck to do freehand. But if you go to my website, blackforestsigns.com, I have the VCarve plans available for download. Go to blackforestsigns.com and go change the category to plans on my catalog page, and you'll see plans for Stumpy Nubs drum sander, not the plans, but the CNC project plans that you can carve out most of the stuff on your own. And so you can basically cut the parts fairly quickly if you want to build this sander. You'll have to buy the plans from Stumpy, and then for $10 you can get my VCarve files that'll cut 80% of this project for you. Okay, so we are all set. I have a 3/4 inch piece of plywood. I have a 1/8 bit end mill, and this is going to cut out a bunch of miscellaneous parts that frankly would be difficult to do freehand and with a table saw. So if you do buy my project plans for VCarve, you have to remember I do all of my homing from the middle of the board, not from the back. So be sure and make sure that you set your machine up to go to the middle of the board. So we're homed, we're positioned. We're going to do a quick Z-axis probe to tell the machine where the top of the material is. And so we're going to do that now. Okay, so now the machine knows where the top of the material is. All we have to do is set the dust collection and start it on its way. So this is the finished piece that you just saw me cut out. This is a side piece that holds a bearing. Where's the bearing? So the bearing will fit right smack into that recess, and then I've cut some hardwood, hard maple flanges that will screw to hold that bearing in. These long pieces are the pieces that stretch the conveyor belt that run the piece through the drum. And so the MDF slides on these pieces. This is a crank that turns the conveyor belt. And you can see that the project file even cuts out the hex nuts that are going to be epoxied in place, which makes quick work of that. I mean, to chisel out a hex nut takes a little while. So that's these pieces, which you'll see me assemble in a few minutes. But then I did a prototype. I didn't show you because I was experimenting, but these are for the drums, and these hold the large nuts that will be epoxied in, and the indicators that'll line up with spinning the drum. But again, the CNC machine makes quick work of cutting out these hex nuts, cuts them to the proper depth, and it cuts the small hex nuts very well so they can be epoxied in. So in the final outcome, one of the project files cuts out all of these wheels that go on the drums and all of these small wheels that go into the PVC to turn the conveyor belt. So it saves a whole lot of time. I hope you at least check it out. And so now we're going to start doing the assembly.
And then when that's dry, you can start pre-assembling both sides of the conveyor belt assembly. And before that, I used cloth electrical tape. Cloth, not the plastic stuff, but the cloth stuff, and that helped me get some traction on the conveyor belt. If I had to do it again, I would use an inner tube from a bicycle tire, and if I ever take it apart, that's what I will use again. So you have to make sure everything's loose and spinning, and then align both sides up with each other, which is sometimes easier said than done. And then you take a short piece of threaded rod, put 2 nuts on it, and insert it in between these, and that's what we will use to push them apart to tension the conveyor belt and get it to track properly. This is a replacement conveyor belt for a jet thickness sander. I forget what model. And then I think I mentioned that I'm making this wider than the original plans, so I cut these tubes to a little over 22 inches wide, and started the rough assembly on those. Made sure they were square, and then you have to epoxy the plywood pieces into the ends after you're sure they're going to fit. And then I shot 3 little 1-inch brad nails into the end of it just to secure them. Well, I'm back. I got to admit, it's a few days later than the last video, so I'm pausing the fast motion assembly to explain a few things. I have not taken all the videos I probably should have taken, the step-by-step procedures, but I'm at the point right now where I have built the axle for the drum assembly, and that's simply one of these round pieces that I previously showed you that has the nut epoxied into it. So I threaded it. Before that, I epoxied in these pins, and that's what's going to engage with the drum to activate it, to make it move. And so there's another big nut that's been epoxied to the axle there, so that this can't spin freely and move back or forth. So the axle has been installed. I have flattened out a spot there for the pulley. And then on this side of the machine, I installed 2 hanger bolts, which have a wood screw side and a machine screw side. And that is for holding up the other side. Before I show you this, let me show you. You put 2 screws into this end, and you can use that to adjust the side-to-side movement of this axle if you have to true it up. And then putting it on these hanger bolts allows you to adjust the up and down motion of this, the axle for the drum, so you can get the drum precisely where you want it to be. And you do that with these hanger bolts. So that part all worked out really well. But now I have a problem. It's because of the motor that I bought. So this axle will spin very freely there. I wanted to use the motor mount that came with the motor, the way it was mounted to the table saw that it was attached to. And I wanted to use the weight of the motor to tension the V-belt between the pulleys. But as I look at it right now, in order to use this fulcrum down at the bottom, the way this motor mounts so that the drum turns correctly towards the feed, this part of the motor sticks up so far that the conveyor belt will not lower low enough to get thicker pieces of wood in. So I'm going to have to take this apart and do a different method to mount this. Probably just mount it flat and just get the correct V-belt one that works. But I'll be back to show you what I figured out. And also I built this stand for the sander to put it at the right height, a good height for me to use it. And I just built it out of 2x4s. I'm going to put a shelf there at the bottom. So I didn't really take videos of that because I know all you guys can do that without being taught how. But I added this extra section up in front here because when the piece comes out of the conveyor belt, some of them are going to be a little bit big, and I didn't want to have to support it and crank the conveyor belt at the same time. So I'm going to put an adjustable outfeed table somehow on the end so that my pieces can just come straight out and land on something. So we'll figure that part out when we get to it. And one of the other things I did is I cut the PVC tubes to the proper length, and epoxied in the plywood circles that I had previously cut out. Now I made a mistake, and the one that's recessed to 1/2 inch was supposed to be the one without the indicator holes in it that mount up to this. But even though I made the mistake, all I had to do was drill it out. So let me show you how this mounts. Well, because the axle is a threaded rod and the holes that it goes through are pretty tight, it takes a little finesse to shove the drum in over those threaded parts. But then you spin the end on and you put the side piece on, the other bearing. And here is where I'm starting to assemble the housing that covers up the pulleys and the drive belt to keep little fingers out of the way. All I did was cut everything to size and then put a dollop of glue in the corners and then shot a couple of 3 brad nails into the side. And then attach the faceplate with glue and brads. And then I had a 4-inch port for the dust collection that I mounted in the appropriate place and just screwed it to the housing. And then I had to take a piano hinge and cut it to the proper length. And then I screwed it to the proper place on the housing. Used the screws that came with the kit, or the hinge, and then just lined everything up and screwed it to the machine. And then the top piece goes on from hanger bolts. I had to mark the location of where I wanted the hanger bolts, use some jam nuts to twist the hanger bolts in place, and then we will use flat washers and wing nuts to mount the top piece. And I have a clasp to hold the housing assembly together. Okay, well, I finally got the motor attached. The method I figured out, sorry for this camera movement so abruptly, is I had to put a second piece of plywood down to raise it up, and using the slots in the motor mount, I was able to push with clamps to get, to get this proper tension deflection over here. So I'm ready to mount a drum and plug it in and see what happens. Hopefully it'll just turn without too much issues. We'll see. Stay tuned. That's basically the same way that you change drums. I'm going to have 3 different drums prepared. One at 80 grit, one at 120 grit, and one at 150 grit. And that will let me very quickly and inexpensively change drums. So, cross your fingers, we're about to plug it in for the first time. And we hope it doesn't explode. 3, 2, 1. We have a good bit of vibration going on. I see the belt flapping in there. That might be part of it. We'll do a little exploring as to what we can do to prevent that, and I'll get back. But that's the first smoke test. Okay, so here is the finished assembly. The top is fully adjustable. I haven't tightened it down yet because I'm going to adjust it to get a perfect cut over the top. It's a dual stage sander, so you can just run a piece across the top, or you can put a piece in and crank it through. And then with this micro adjuster, you can crank the board up just by a couple of thousandths at a time. So this is a quick connect. You can fast adjust it, or you can tighten it down, and you can adjust it in smaller increments. Now when you change the pivot points on the front, there's several different pivot points. I can actually sand a board that's going to be 4 inches thick. So I can't get much thinner than a ½ an inch, but if I have pieces that are thinner, I'll just double side tape them to a sled and run them through on another piece of wood. So right now I have to finish the finer adjustments on getting the conveyor belt perfectly parallel with the drum, and then after that I'm going to run this piece of wood in under the drum, crank it up a little bit and turn on the drum, and this will sand the drum perfectly level with the conveyor belt. So basically, when I put a piece of wood through it, it'll be exactly the same and flat across the whole piece, the same thickness all the way through. So after I sand the drum, then I take the drum out. I'll glue the abrasive paper to it, which I'll show you in a different video, and this thing will be ready for action. So stay tuned, we're in the home stretch. So like I said in the previous video, I cut a piece of wood, which is as flat as I could find, and I stapled some 60 grit sandpaper to it along the top, and I ran it under the drum after I got the drum parallel to the conveyor belt. And I don't know if you can see it, but I now have an equal amount of cuts in the drum. So I think the drum, it was vibrating a lot when I started, and now the machine is not vibrating very much at all. So the drum was kind of out of balance. It took a long time on this side, so it was thicker over here than it was over here. So anyway, now I'm just going to spray it with 3M adhesive and put the belt on, and then we'll sand a piece of wood. So I'll put a link at the bottom of the video where I got these sanding belts. They're basically for belt sanders, but they're fairly cheap, and this system, doing it this way, it's a pretty inexpensive way to do it. So now I'm just going to spray it and start winding the sandpaper, and I'm using 100 grit for this one. Hey, this is going to be the very first test of my dual stage sander. This is the sander that will crank the wood through on this drum that spins. And the reason I call it dual stage is I can sand things across the top as well.
Where does the wood
So
go?
the wood goes in here. I've been waiting to do this Chinese checkerboard until this was done. So it goes in and it touches the, see there's high spots here, and it's gonna start sanding them down. Hopefully everything works. The dust collection is on.
Yeah, see, he connected it here.
Yeah,
And
so,
he sealed all that up over there.
yeah.
This is very exciting.
So it's gonna make noise. I will be doing this with it running, but now I crank this up a full turn, and that raises the table up, then we send it through again. So it's going to take at least 6 passes, so cancel now and we'll come back when I'm done.
Now that you're totally coated with sand,
Sawdust.
from sawdust head to foot, what were the results?
I'm very pleased. A couple things broke down in the middle. That's why I have this little ridge here, but I can fix that. And the best part is, this is 927 thousandths, and this is 926 thousandths. So it's sanding perfectly
Show us
flat.
the others. What was the side that had all the blue paper sticking out of it?
This side.
That's awesome.
So after I cut the Chinese checker stuff, I'll do a little bit of orbital sanding just to finish it. But the important thing is that I got a flat piece of wood to do my CNC stuff with.
Nice. Congratulations.
I'm gonna have to improve the dust collection.
Yes.
Yes, it did.
To figure it
I'm
out.
very happy with it all.
Congratulations. Great
Yay.
job. Yay.
Hello again. After editing the video that you just watched, I realized that I made a big mistake. I was having trouble keeping the drum parallel to the conveyor belt after changing the belts because this adjustable part, I couldn't, and I just realized I missed a whole step. This is a piece of plywood with 2 screws on the end of it, right there, that you can micro adjust once you get the machine drum parallel to the conveyor belt by adjusting these screws. That means that the next time you change the drums, since they're all sanded the same, that you get the precise placement of the drum after adjusting these. So I didn't want you to make the same mistake. Hope you enjoyed the video. Please subscribe, hit the notification button if you want to be notified of the next videos because there's a lot coming up. And so thanks again, and see you next time.